So we're going to see solving equations part 1. So first, when we're talking about solving equations, we'll talk about linear equations. So linear equations are when the highest power on the x is a 1. So this is just an x. It's understood that the power here is 1. So it's not x squared or x cubed. So this would be the type of equation you're solving. So to solve the equation, we want to isolate the x, which means to get the x by itself on one side of the equal sign. So you can think of this equal sign as like a wall. You're going to keep the 7 on that side of the equal sign and the 2x on this side because we're trying to isolate the x. We want the 3 to be on the other side. So what we would do is subtract it. So if we subtract the 3 on this side, it's gone. So basically you're moving it to the other side and it becomes a negative. It was a positive on this side, so we subtract it to balance it out on the other side. So now we have 2x equals 4. Divide both sides by 2, and that gives us x is 2. For any of these, you can actually check your answer. Anytime you're solving an equation, you can check your answer by plugging the number back into the original equation. So that's 4 plus 3, which gives us 7. Okay, so a second example. Say we had minus x plus 3 equals 7. So the x is on the left-hand side, and we want the 7 to stay on the right-hand side, and again we need to move a positive 3, so that would become a negative 3 on the other side. Now we have a minus x, so you can, the number up here that was in front of the x was a 2 that we divided. Here it's a minus 1, so we would divide both sides by minus 1, and that would give us x equals negative 4. So just for anyone that's been out of school for a while, sometimes I get questions about this type of thing. So this is, a minus sign can actually go on top or on the bottom, and this number is just a 4, but it can go out front as well. Where it can't go is on both, because this whole thing is negative. We would simplify it, but these are all equivalent, they're all the same, okay? Number 3. So we can add a bracket into this. So we've got two terms here. The term is separated by a plus or minus sign. So in this first term, we want to get rid of that bracket. So the bracket is multiplied by a 2. So what we would do is multiply that 2 by each term inside the bracket. So 2 times x is 2x, and 2 times a positive 3 is a positive 6. And do the same thing here with this negative 4. So that's a minus 4x. Be careful to take the sign with the 4. And a minus is a plus 4. And then we do the same thing. But you notice that we've got a 2x and a minus 4x. So 2 minus 4 is minus 2. And we've got a 6 and a 4. They're both positive, so that would be 10. And then we've got a linear equation just like we were doing up here, where we're just rearranging. So the minus 2x would stay on that side, the 6. We want to move the 10 over to the other side. That becomes a minus. Minus 2x equals minus 4. Divide both sides by negative 2. Negative over negative is a positive, and 4 divided by 2 is 2. And again, you could check your answer with any of these. So just take the original, and everywhere there was an x, we're going to plug in the 2. And hopefully it will work out to 6. So this is 2 times 5 minus 4 times 2 minus 1 is 1. 10 minus 4, just 6. Okay, so that would be number 3. Number 4. Do the same thing but make it a little bit more complicated. So here we do have a bracket, and that has the 5 in front and negative 5, so we're going to multiply that negative 5 into the bracket. Now this 1 is in front, and it doesn't have a sign in front of it, but it would be a positive. So we rewrite the 1, we're going to multiply the minus 5 by x, and then the minus 5 by minus 2. So here's our equal sign. We want the x's to be on this side and the numbers to be on this side. So really that's all that we want to stay. We want the x's to be on the left and the numbers to be on the right. So we need to move this 3x to the other side. It would become a minus 3x. We want to move the 10, would be a minus 10. We also want to move that 1, and it's a positive 1, like I said, on this side, so it would be a negative 1 on this side. So here we have negative 8x. Minus 1 plus 2 is 1. 1 minus 9. Or you can do this anyway. You could do 2 minus 1 minus 10. So that's 2 minus 11. You could do it that way. Divide both sides by negative 8. Negative over negative is a positive, so 9 over 8. And this would go back, if we were checking this goes back to what we did earlier with fractions. So 1 minus 5 times 9 over 8 minus 2 equals 3 times 9 over 8 plus 2. So here we would do a common denominator. 9 over 8. If I was going to put that over 8, I would multiply the top and bottom by 8, so minus 16 over 8. Here, you multiply the top, would be 27, and the bottom would be 8. 9 minus 16 is negative 5. And now this 5 is multiplied in, so negative 5 times negative 7 is positive 35 over 8. Okay, so we just need to make sure that these two sides are equal. So this would be an 8 over 8 plus 35 over 8. 35 plus 8 is 43. 27 over 8 plus 16 over 8 is 20, 30, 37, 43. 43 over 8. Okay, so checking your work sometimes is a little tricky without a calculator, but we do know how to do fractions, so you should be able to do that, no problem. That would be something you'd be expected to be able to do. Okay, so the next type is if it involves fractions or rational functions. So let's write that down, rational functions. Those are solving equations that involve fractions. So an example of that would be 3 minus 2x over 5x plus 1 equals 2. So here, let's call this case 1. And let's say case 1 is that we have a fraction equals a number. Okay, so the method is that we're going to use to solve this is to cross multiply. So we've got a fraction, a over b, and that's equal to a number. So the method is going to be that we're going to take b, the denominator, and multiply it by the number. So a equals the number times b, and that will make it not into a fraction. We'll be able to solve it like we were doing in the first few examples. So for this one, we're going to take that 5x plus 1, that whole thing, and multiply it onto the other side by 2. So we'll have 3 minus 2x is equal to 2 onto 5x plus 1. And then we've got a linear equation that does not involve a fraction, just like we've been doing. Multiply the 2 in. Just rewrite everything while you do that. and then rearrange it so that the x's are on one side. I'm going to move that 10 over. And this already had a 2, and we'll move the 3 over. So minus 12x equals 2 minus 3 is negative 1. So x is 1 over 12. So basically, when we start an equation with a rational function, we are looking to get rid of the fraction before we start. Okay, so let's say example 2. And you could check these as well. When you check them, always go back to the original equation to check. So these are nice when it's equal to 0, actually, because when we take that denominator and multiply it on top, we get 0 times something. And 0 multiplied by anything is 0. We don't even really need to write this out because that's going to be 0. So we have 5x plus 10 is equal to 0. Rearrange it, divide both sides by 5, and we get x is negative 2. And again, we could check our answers. 5 times negative 2 plus 10 over 4 times negative 2 plus 11. 5 times negative 2 is minus 10. 4 times 2 is minus 8. So we get 0 over 3, which is 0. Okay, number 3. So number 3, let's say, is case 2. So we're going to do case 2. Is a fraction equals a fraction. And we'll do a couple examples of this. The one I put here, the fraction on the right-hand side, just has numbers, and that's fine. It could also have variables in it, so we will show an example of that type as well in a minute. But we're going to do the same thing. We're going to cross multiply. So if we had a fraction on each side, we're going to take the denominator, multiply it on top, and that's what we did before, but we're going to take this denominator and multiply it on top. So then we'll have a times d is equal to c times b. So we're cross-multiplying, and then we have a linear equation to solve that involves just working out any brackets and moving things around. Okay, so our example here, we're going to multiply the 3 times the x plus 1. Make sure you put a bracket around the x plus 1, because the 3 is going to multiply by the whole thing, equals 2, and we're going to multiply that 5. So here we have 3x plus 3. And 2 times 5 is 10. Move the 3 over. And we'll get 7 over 3. Okay, number 4. Okay, same idea, fraction equals a fraction. We cross multiply the 3 on top and the x on top. So 3 times, make sure you put that in a bracket, and then x times 2. Multiply out your bracket, and then we rearrange. So we're going to move the 2x over and the 15. So 9x is going to stay. We're bringing the 2x over. It was a positive on this side, so it will be a negative. The minus 15 is a negative on this side, so it will be a positive on this side. And don't write it as a mixed number, just leave your answer as a fraction. Let's check this one. We haven't checked one by plugging a fraction in. So you'd have 3 times 15 over 7 minus 5 over 15 over 7. And hopefully that will be 2/3. So let's just work out this side and see if we get 2/3 as an answer. So on the top we've got 3 over 1 times a fraction. So 3 times 15 is 45 over 7 minus 5. If we want to put that as a common denominator, we would go 35 over 7. So 45 minus 35 is 10 over 7, divided by 15 over 7. Now remember, when you divide by a fraction, you multiply by the reciprocal, so we would flip that over. So we end up with 10 times 7 over 7 times 15. These cancel. We get 10 over 15. That's a 5 and a 2, and this is a 5 and a 3. And we get 2/3, which is what we were looking for. Okay, so just go back. Here it's a fraction over a fraction, so we flip this one over. Instead of 15 over 7, it will be 7 over 15. These 7's will cancel. We get 10 over 15, which can simplify to 2/3. Okay, so another example, still the same type, but I'm just going to put the x's in different places. So that was number 4. So number 5, 2x minus 5 over 2 is equal to x minus 1 over 3. Okay, so again, cross multiply, multiply the 2 on top and the 3 on top. Make sure you put those terms in brackets. So that 2x minus 5, we want to multiply by 3 by the whole thing. And 2, we want to multiply by x minus 1. 6x minus 15, 2x minus 2. Rearrange, so we're going to bring the 2x over to this side with the 6x, becomes a negative. The minus 2 is already on this side, and we're going to bring the 15 over, it'll be plus 15. So 4x equals 13, and x is 13 over 4. Okay, and by plugging that into the original, you could check your answer using common denominators. Okay, same idea, x times 6, and the 5 times that, bracket, and it's a linear equation. So 10 minus 20x is equal to 6x. The minus 20x is on this side, we'll bring the 6 over, and the 10 to the other side was going to be a minus 10. Divide both sides by minus 26. The signs, and these are both even, so they will simplify. So 5 over 13. Okay, so next, same idea, but we're going to go one step further. So first what we saw were linear equations. So we started with something like this that you just rearrange. And then I added in the fraction bit where you cross multiply. So what we're going to do is go even one step earlier, that we're going to have a fraction that we need to find the common denominator for first to make it into one fraction. So we'll call it case 3. An example will look like this. Okay, so what we have is 2 fractions and a number. So we'll call this case 3, where we need to find a common denominator first, and then we cross multiply. So you cannot cross multiply when there's 3 terms. So this is like a fraction plus a fraction, or minus, is equal to a number or even another fraction. So we're going to start with this. We want a common denominator between the 2, so that would be 12. So we're going to multiply this one by 4 to get a 12, and this one by 3. So here we will have 2 onto x minus 1 times 4 over 12. And here we will have 3 times 3x plus 1 over 12. So 2 and 4 is actually 8. Oops. We can multiply that 3 in. 9x plus 3 over 12. Multiply this 8 in. Now be careful when you subtract fractions. We want to subtract this whole thing. So when we write this out, this will be minus 9x plus 3. So 8x minus 8 minus 9x minus 3. That's what most people forget, is that minus sign. So now in the numerator, on the top of this fraction, we have 8x minus 9x is minus x. Minus 8 minus 3 is minus 11 over 12. Now the other side, all the way down, we had a 2. Notice I don't have equal signs on this side. Okay, there's only one equal sign on each line when you're writing math, and our equal sign is in the equation itself, so we wouldn't put it in the front, we just write one line under the other. So now we're back to a fraction equals a number. And we're going to cross multiply, so the 12 times the 2. Move the 11 over. And divide by negative 1. So we get x is negative 35. Okay, so we'll just do a couple more examples of these. This wouldn't be too difficult to plug back into the original. You could actually go, you would have to do your common denominator once you plug it in, but you could check your answer easily enough. Okay, so here our common denominator would be 5 times 3 is 15, so multiply this by 3 and this by 5. So we'll have 3x over 15 minus 2 times 5 is 10x over 15. Write it as one fraction. These are both x's, so they combine. And now we have one fraction equals a number. Cross multiply. Divide both sides by minus 7. And we get x is minus 15 over 7. Okay, so let's just do a check. I'm just doing them randomly once in a while, but if this were on a test, I would definitely be checking my answer. So I'm just plugging in the minus 15 over 7 everywhere that I see an x. I'm going to simplify this, and hopefully it will equal 1. So here we've got a fraction over a fraction. So this would be minus 15 over 7. Instead of 5 over 1, 1 over 5. Here, let's just simplify the top here first. This is a minus 2 times a minus 15. Or you could keep the minus there. 2 times minus 15 is minus 30 over 7. So now minus 15 over 7 times 5. And here, minus 30 over 7 times, flip that over, 1/3. I'm just going to rewrite this. This would be a plus 30 over 7 times 3. Now I didn't multiply these out because I can actually see that they would simplify. 15 is 5 times 3, so the 5's cancel. And 30 is 3 times 10, so the 3's cancel. So I have minus 3 over 7 plus 10 over 7, which equals 7 over 7, which is 1. That's the right answer. Now that's a bit trickier to do. I would practice that because it's something that you're required to know how to do, is to be able to plug a number in that's a fraction and then rearrange it and solve. So I would go back over that and practice. Now I'm giving you this one as your first instinct, because of the examples we just did, might be to combine these as a common denominator. But this is a 0 over here, and 0 is a number. But if I move that 2/3 over to the other side, I don't actually have 3 terms, and I can go right into cross multiplying. So I'd multiply the 3 and the x. So 3 times 3x minus 5 minus 2 times x, which is 9x minus 15 minus 2x, 9x plus 2x, that's bringing that over, the 15 to the other side, 11x equals 15, and x is 15 over 11. So just watch this. This had a equals 0, so I would rearrange it first. Okay, so that's the end of that section. And go and practice those.